Hey there, everyone, Alejandro, and welcome back for day 201 of me doing the Daily LeetCode challenge until I reach 1 year's worth of great contributions here on GitHub. So today's promise for February 2nd, 2025, and without further ado, let's get straight into it. Okay, today we get a LeetCode easy, problem 1752, check if array is sorted and rotated. Given an array nums, return true if the array was originally sorted in non-decreasing order, then rotated some number of positions including 0. Otherwise, return false. There may be duplicates in the original array. An array A rotated by x position results in an array B of the same length such that A of I is equal to, oh my gosh, okay. I plus x modulo, what? Okay, 3, 4, 5, 1, 2, true. What? Wait, okay. Given array nums, okay, so it's a LeetCode easy. So okay. If the array was originally sorted in non-decreasing order, so increasing, but strictly increasing, right? Okay. Or no, is non-decreasing, increasing or equal? What the heck? An array A rotated by x position such that A of I is equal to B of I plus x modulo A dot length? What? Index I plus, so it's about the indices? Oh, no, it's about the p-values. Wait, results in an array B? Okay, I'm so confused. 3, 4, 5, 1, 2, 1, 2, 3, 4, 5 is the original array. You can rotate the array by x equals 3 positions to begin on the element of value 3. Oh, by rotated it. Okay, I don't understand this notation, but is it just like basically the array starts somewhere? Okay, so basically find the smallest number in nums and then just see if it's sorted from there, right? Okay. Is that what it is? Like, for example, here you just go to this one and then just like you check if it's sorted for the rest of the array. Okay, I see what's happening here. Face to face with greatness and it's strange. Open your eyes, let's begin. Smallest index equals none. Float of infinity, let's begin. Starable. That's the smallest num. Smallest num equals num. Smallest index equals, well, for I, num. And enumerate nums is equal to I. Then we'll say, okay, prev num equals smallest num. For this, x equals smallest index. For this in range n, we'll do index plus or equal to 1, index modulo equal to n. Here we'll have a lambda function get next index, or here we'll just call it next index. Index plus 1 modulo n. There we go. Those next index of smallest index. Here we'll say loop invariant equals next index of index. Equals nums of index. Prev num is num. Can it be less than or equal? I forget what non-decreasing means. Does non-decreasing mean it can be increasing or equal values? Right. Num is equal to index. If it's not the case that prev num is less or equal to num, then return false, right? And then otherwise, here, once we've done a full rotation of the entire array, we just return true, right? That's what I'm going to take the problem to mean, because that's what it seems, right? If I take the understanding of rotated, here, not really, right? Okay, print f string smallest num equals smallest index equals print f string prev num equals num equals. Oh, do I just do, wait, what? Prev num, wait. Num is 2. Then prev num is 2. Why is num 2 again? Should be nums of index. Next index of index. Next index. Should get me the next index. Okay, index plus or equal to 1. Index modulo equal n. What? Why is prev num the same as num? That should not be the same. What? This is my loop invariant. Prev num is equal to num, which is of index, which I keep updating. Why is this not? Why? What is going on? What? What is happening? That's not what it's doing. Num is equal to nums of index. It's called nums. Okay, this is weird. Smallest index plus 1 modulo n. Bro. What is going on? At 4 and 0 is the same? How is it the same? Bro. Case 1, mate. 0, 1, 2, 3, 4, it is 2. At index 0, Maybe because I'm doing it this way. Okay, lol. Maybe it's because I need to set num before I print. Okay. 3, 2, 3, 4, 5. Okay, this is exactly what I thought. What the solution to this is just doing n-1, right? Voila. Okay, let's submit this. Wrong answer. What's wrong with this answer? Oh, does it have to be a less than sign? Is it this? Does non-decreasing mean strictly increasing? Is that what it is? No. Expected true. Rev num larger than num. Okay, let's do ourselves. What's wrong with this guy? We're getting false. Okay. So here what's true. So you can go 6, 6, and 10. I guess we'll just do less or equal, so that way we get the smallest from the right? Yeah, I see. And now what if I do greater or equal? Then I'll fail to case 4 is what I bet. Yep. And here. Yep. So now we'll pass because, okay, it means that you can have things that are equal. Okay. Now we can submit. Wrong answer. All right. We're gonna get it. Slowly but surely. 1111379, and yeah, we should be getting true. Now, okay, this is one of those cases where it's like, okay. True. I don't want to necessarily go to the left most. Oh, but that'll make the algorithm at most n squared. Oh, but we can. Lol, so we can. Huh. Yeah, if anything, we could do something like this. Right? Yep, so that works. There we go. Submit. And there we go. Complete this streak 201 days. Consistency is key. See ya tomorrow. Okay, so here, okay, I'm betting you there's probably an O(n) way of doing this. Here, just like, okay, let's just write an O(n) squared algorithm and so on just to get a working solution. All right, we can get rid of some of the print statements up in here. Yeah, this is cool logic. We don't need next index for sure. This, we could do prev num is equal to nums of index. Yeah, this is fine. It'll just be one more iteration. Index. For one. I'm actually surprised this works. Index plus 1 modulo n. Nice. Okay, 0 mess beats 100%. That's interesting, right? Is there a linear runtime solution to this? Not sure, right? They just want you to... This is a really, really weird way of asking if something is rotated, right? I really just went off of this word over here. Right? Here you can say like... is equal to... If num is less than smallest num, elif num equals smallest num, c's.add There you go, something like that. No? Really? Oh, with I in it, of course. There you go. Okay, so like, yeah. This is still technically n squared, but it might make things an even bit faster and so on, so... There we go. I mean, it's a LeetCode easy, so you're not supposed to go too crazy anyway, so we can keep the solution as is. There we go. Bada bing, bada boom. So, as always in my videos, I do a quick recap. I always will solve the problems. For this one, maybe there's an OVN way of doing about this. Since it's a LeetCode easy, the constraints are super small and so on, I was like, you can do it squared if you really want to, and I did technically a slight little optimization. So basically, you want to check if the array was sorted, and then rotate it, right? Which basically means like, okay, for example, here this array is indeed sorted and rotated because it's like here if you start at this 1 and you go through the rest of the elements, it's in sorted order, right? So basically the question is there an index such that if you start from that index and go through all the elements in order, where it's like if you're at the last element, the next element is the one at the beginning, would it be in sorted order, right? So like for example, if I start at 1, it would be 1, then 2, then 3, then 4, then 5, which is sorted. Right here, if I start at like 1, then 3, then 4, then 2, then it's like, oh, it's not sorted, right? Because I go 1 to 3 to 4, then from 4, I go down to 2, so it's not sorted, right? So essentially, the idea really is like, okay, why not just go to whatever the smallest number in the array, right? And from there, check if it's possible, right? Because the smallest number is definitely going to have to be at the beginning of a sorted array, right? So you might as well start only from the smallest number, right? Now, the only tricky case is for something like case 4 here, right? If you start at this 6 over here, then this is bad, right? Because you start at the 6 and the next value is 10, but then it's 6, which is like, okay, it's not sorted order. But if you start at this 6, which is the same value, you start at this 6, go to the 6, and then go to this 10, it is sorted order, right? So maybe you'd think, oh, why don't I go to the rightmost 6, right? So out of all the smallest numbers, I always choose whatever's the rightmost one, right? Well, you can't always do that because of cases like case 5. Here, the smallest number is 1. And if you started from the rightmost one, then you have 1, 3, 7, 9, and then you go from 9 to 1, which is not sorted. You have to start from the leftmost one and then go from those and then all the way up to 9, right? So here, what I did is like, okay, how about we're going to find the smallest number in nums, but we're going to keep track of every index of that smallest number, right? So at the very beginning, I'm going to say my smallest number is infinity, and I have no smallest indices. Then I'm going to loop through every single index and num pair instead of nums. So here I'm going to say, okay, if the number is less than the current smallest number, that's like, okay, I found something even smaller. So I'm going to set that smallest number to this. I'm going to clear whatever was in this array and only have this index, right? Because I just found a number that was smaller than my previous smallest number. So everything that's in here can only be bigger numbers, indices that map to bigger numbers. So I'm going to clear them all out, and all I care is about this index, right? Otherwise, if I find a number that is currently equal to my smallest number, then I'll be like, okay, I'll append that to my current indices that point to the smallest number. And then if I find one that's even smaller, then I'll clear all the indices that are in here, add only the one with the smallest num. So that way, at the end of this one iteration loop, I'll have the indices, for the smallest number in the array, I'll have the indices for where every single index in which that smallest number occurs instead of nums, right? Which in the worst case might be every single number, right? And then here, what I will do is for smallest indexes and smallest indices, right? These are the only possible really starting points that I care about the array, right? One easy way is to essentially consider every single index in the array as a starting point and then do an over n loop, which will make it n squared, and it definitely works. Here I just added the small optimization of like, okay, I know that if I'm gonna have an array that is rotated and then want to check if it's sorted, I'm gonna have to start at whatever is the smallest number in nums, right? So I might as well only consider indices where the smallest numbers occur, right? So here I'll only loop through the smallest indices set that array that I have up above. So for each smallest index in there, okay, I'll set index equal to that smallest index. I'll say, okay, prev num is equal to nums of index, res is equal to true. Prev num, okay, initially I'll have, the num at nums of index and prev num at nums of index, but remember, we want it to be non-decreasing, so things can be of equal value, and that'll be okay. So that way, when I compare prev num and num when they're the same number, it doesn't actually return false, right? So we're chilling there. So that's why I can do that. But otherwise, I loop through every single number, because essentially what I'm going to do is one full rotation of the array, right? For example, I start at this one. I'm going to go from 1 to 2 to 3 to 4 to 5. I'm going to do one full scan of the array, where it's like if I'm at the last element, the next element will be the first element, right? So here I'll say, okay, for n many iterations, where n is the length of nums, I'm going to keep going through the next index and making sure that the current number is greater or equal to the previous number, right? So num is equal to nums of index. If prev num is larger than num, then that means I don't have things in sorted order. So I'll set res equal to false when it was originally true, break, and then break out of this for loop, and then I'll be like, oh, res was not true, so therefore I'll continue on over to the next smallest index, right? Otherwise, it's like, okay, if prev num is less than or equal to num, things are good so far. So how about we just look up to the next index, right? So here we'll set prev num is equal to num, and then index will be index plus 1, and we modulo by n, so that in case we're at the last index, when we do plus 1 modulo n, we go back to the front beginning index, right? So that way we do one full scan of the array, and if we did a whole for loop here and we never ended up breaking, that means we have a sorted version of the array. So when we're done with the for loop, we say if res, then return true, right? So res is kind of like a flag, right? Maybe I shouldn't call it flag res. It's like is sorted is equal to true, right? And here we'll say if is sorted, then we'll return true, right? So maybe that's a better naming convention right there. Okay, maybe we should rename this right there. That's my bad, but now we should be a-okay. And there we go, 0ms beats 100%, right? And at the very end of the day, if we loop through every single smallest index and never it was the case that we were ever return true, that means the array is not a rotated version of a sorted array, in which case we'll just return false. And there we go, bada bing, bada boom. That is pretty much it in terms of how I was able to solve this problem. And yeah, so hopefully that solution makes sense. And yeah, but otherwise, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I would highly appreciate if you left a like or a comment. But otherwise, I'll catch you next one. So till then, ciao, ciao, my friend. Bye-bye.